Hello friends, so today in this video we're gonna discuss three problems from LeetCode. All the three problems are related to each other. The three problems are Jump Game 1, Jump Game 2 and Jump Game 3. The first problem and the last problem is a medium level problem and the second problem is a hard level problem. So stay tuned with me and we'll discuss all the three problems one by one. So the first problem states that you are given an array of non-negative integers as you can see in this example, and you are initially positioned at the first index of the array. Okay, now each element in the array represents your maximum jump length at that position. So if you are on the first position, you can jump a maximum of 2 blocks from this position. As you can see, you can reach 3 or 1, and then again from 3 you can reach 3 blocks or 1 blocks. Now you have to determine if you are able to reach the last index or not. As you can see in this, you can reach the last index because you can jump from 2 till 3, and then from 3 till you can jump to 4, or you can take any path, like you can jump from 2 till 1, from 1 till you can again jump 1, and from 1 you can again jump 1. So you don't have to optimize the number of jumps, you have to just tell that whether you can reach the last box or not. But in this, as you can see, if you take this like if you start from this point, if you jump 3 steps you will land out to 0, and if you land out to 0 you will not move ahead. From 2 you can again land out to 1, like 0. From 1 you can again land out to 0. So all the paths land down to maximum of 0, and thus you cannot move past 0, and thus you cannot reach the last block, so answer is false. So in this problem, as you can see, if you understand the question itself and the examples, it's just like from every index what is the maximum index you can reach, and can you extend the maximum index you can reach. What I mean by this is, for every index you can find out what is the maximum index you can reach, and then for all the other indexes, if you do a for loop from 1 till n, for all the indexes you have to increase the maximum index. So it's like just you have some bar, you are moving from left to right, and from the first point you set your bar at this point. Now from the second point, which means that you can do a maximum jump of this point. Now for the second point, whether you can do a maximum jump less than this or more than this. If you can do a more than this, then you can shift your bar to this point. From the next point, if you can do more, or if you can do less, then you cannot shift it, or if you can shift it, you can shift this bar to even more. So you have to just check that whether you can shift the bar slightly by one by one, such that you can make the bar go extend the outer bound, and thus which means that you can go and this is possible. But in this is not possible. So there can be two ways. You can either do this greedily. In greedily you have to just do it in O of n, or else you can also do this in a DP manner, in which you can make a DP table of O of n size, and then what you can do here is, for every index mark out what are the index you can reach. So as you can see, from this index 3 you can reach this and this index. Okay, from this 2th index you can reach this and this index. From this 1 you can reach only this index. From 0 you cannot reach an index, and 4 you are on the last index. So then you have to just check that whether from this index can you reach the last index or not. So as you can see, if I tell you from this, you can move from left to right, and then you can reach the last index. So you can make a boolean variable, boolean table, as you can see, of array, and then the last index is always true. Then from this index you can have to check that whether in one step you can reach the last index. But because as you can see, you have to find out for this value, if you do a one step, then you will reach the last box, and if you reach the last block, then you have to just check that yes, the answer stored in this is true. So you just have to check that any of the blocks stepped at this point tends out to be true, which means that, as you can see, 3 blocks, which means that among all the 3 blocks, because from this point you can jump 1 block, 2 block or 3 block, if any of them is true, which means that if you land on any of those blocks, that will lead to a condition which is true, and you can reach out the falling or reach the end. Okay, so that's the whole logic. These are the 2 codes. If you want to do in a greedy manner, if you want to shift it out, what you can do, you have to define out a last, which means that what is the last value or the maximum value you can reach, which is the n minus 1 value. So you have to just check that whether you can reach that or not, or actually I'm just doing in a you can do it from left to right, or I'm actually doing it from right to left. So what you can do here is, I'm just not shifting it out. So if it means that from every point, what is the back you can go, and you have to just shift it out more so that you can reach 0. and it's just like the same. So the last is n minus 1 from the second last to the 0. What you have to check that whether from the current point I plus nums of I, if it's greater than last, then last is equal to I. What this actually mean by this is, last means that whether what is the last value I can reach. So I have to just shift my last. So as you can see, if the current value I am on plus nums of I, if it is greater than last, so which means that, as you can see, okay, this is the last value I can reach. Okay, now this is my I. Now if my I plus nums is greater than this, like this greater than or equal to this value, which means that now from this position I can reach my last. So this is a valid position. Okay, now I can mark this as my last, which means that now if I go back, I have to somehow reach this position. If I somehow reach this position, from then I can reach down to this position easily. So it means that from the last position, like from every position, I have to just check whether I can reach the latest last position I can do. Okay, latest last is first, initially last is this, which is the last index. Now from the second position, I have to just check that whether I can reach down to this last position. Yes. So I will mark my last to this, because now I have a task to just reach down to this position, so that if I reach down to this position, I can go to this. Now I will go back and back, such that I have to just reach my latest last. If I just reach my latest last, then from latest last I can somehow make a way and find out the answer. And that's the answer, as you can see. Okay, I've also written on this part, which is just like which I've told you, for moving from left to right and marking out that whether for every point I can reach out the last point or not. Like whether, as you can see, it is 3. So for this 3, I have to check that whether among all of them, if anyone is true, which means that from this I can reach the end. And this is a DP solution. This is like sum of sort of O of n square, but it is not actually O of n square. So so it will pass, but it will take a lot of time. But in this, it is a O of n. So this will definitely pass, and it is a very optimized code. Okay, so you can check down the codes. I will put them in the description. The next problem is jump game 2, in which you are given an array of non-negative integers. The problem is same. You are given the same nums of array, but from every you have to reach from the starting till the ending position, but you have to find out the minimum number of steps. Now you have to minimize the number of jumps you have to do. So what you can easily do here is, in this problem, as you can see, this is you cannot do this in O of n square. Okay, so the main thing in this problem is some of sort of some type of greedy approach, because if you because you can do a maximum jump, try to do as maximum jump, because if you do as maximum jump, you can reach the end in the minimum number of possible ways. Okay, so now what I actually done here is, I'll draw it out. I have done the same thing which I have done in the previous question, but just using the minimum number of jumps. So what you actually done here is, let's assume that if you are on the starting point, okay, now from the starting point you can find out what is the maximum jump or maximum position you can reach. Okay, because let's assume that from the starting point, let's assume I can reach the maximum position of 7. Okay, from 0 you can reach 7. Okay, now if you can reach 7, then it can happen that if you can reach from 0 to 7, it will take you one step. Okay, it will take you one step. Now maybe some position in between, let's assume the second number in this, the second block in this path will take you to 10th position. Okay, and then maybe the 4th position, this is 4th and this is 6th position. Okay, the 4th position can take you only to this position, which is 5th. Okay, and the 3rd will take you to also 5th position, which means that if you are on the 1st position, you can go to 6th position, 2nd position you can go to 10th, 3rd to 5th, 4th to 5th, and 6th is the position. Okay, now as you can see, from the current x, I can go a maximum of 6, and all of these steps will take you one step. From 0 till the maximum step I can go, it will take you one step. So what you actually have to do here is, I will just do the same thing. I will keep a bar. Bar means it means that what is the maximum position I can reach from the starting point. It is 6. Okay, now move from left to right and find out for every position till it is like an I. If you can take a I counter and take that out counter, move from left to right till it is not reached the last position. Okay, so as you can see, let's assume for the first position, the last position I can reach is 6. Okay, now move your pointer from left to right till it is not reached the last position. Find out for all the the position which are in between, what is the next maximum you can reach. Next maximum is, as you can see, if I am starting at 2, I can reach the next maximum, which is 10. From starting from 3, now maximum is 5, but it is not the maximum actually. So for all the values in between, you have to find out the next maximum, because see, if you start from here, you can move from this position to all of these positions in one step. Like, because see, in all of these positions, you can go to this, or you can go to this, you can go to this. The maximum you can go to this, it means that among all of these positions, you can go in one step. But now from all of these positions, what is the next maximum you can reach? Next maximum is, you have to find out among all of them, what is the next maximum they can reach. And the next maximum is, let's assume, like 10. So which means that now from after completing this 6th position, after my eye is iterating over now this positions, I have to find out that now from these positions, what is the next maximum I can reach. But for reaching to all of these positions, I can take 2 steps, because see, from 1 step I can reach down to this position, which is the maximum among them. But now for reaching among these positions, because the maximum among them is, so I can reach there by this step, which is 2. So for reaching this, I can take 1 step, and from this I can take 2 steps. So it's a little bit confusing, but the main problem is you have to find out the maximum I can go. The maximum I can go will tell you that among all of the values which are in between, it will also take 1 step, because see, if I take from this to this step, it will take 1 step. So among all of them, it will also take 1 step, and from all of them, you have to find out the next maximum you can reach. The next maximum is this. So what is beneficial? To go to this point with 1 step and go to the next maximum with 1 step. So that's the whole problem. So I'll take down the code part now to even make it more clear. It's a hard problem, but if you understand the code and the logic, it will become more easy. So if n is equal to 1, which means that there is only one block, so answer is 0, because you are actually on the first block, so you don't need to do any jump. Answer is the number of jumps you'll do, the minimum number of jumps. Maximum reach is the maximum reach you can go. So maximum reach for the first element is obviously the nums of 0, which means that the nums of 0 is the maximum reach you have to do. Okay, this is current and this is I. Current is actually just used to store what is the current value I'm on. So current is actually storing out the current maximum, which I have told you that among all the values in between, I have to find out for all the values in between what is the next current maximum I can go. Okay, so that's actually storing out current maximum. You can name as current maximum, which is actually nums of 0, because for the first element my nums of 0 is the current maximum. Okay, but for example, when I reach to 2, my current maximum is this 10, so it will change. Okay, but for this 3 it is less, so all of them are less, but for 2 it will become 10. So among all of these values, I will store out, like, if I start at this value, what is the next maximum I can reach. So that's what I'm doing, and I will do a while loop such that I will do a maximum reach, because I will do a maximum, this is the maximum reach. I will do a while loop such that my maximum reach is less than n-1, then only I can do. If my exceed or greater than or equal to n-1, which means that I have reached the last element, so I know the answer. And what I'll do, among all the values, my current pointer, which is I, is moving from this to this. So for all the values, my I plus the ith value will tell you the current, like the next maximum value I can reach. So if this value I plus nums of I, it becomes greater than current, which means that, as you can see, if I plus 1 becomes greater than current value, then it means that I can get the new current value, like the new larger value. So that's what I'm storing out, and whenever my I, the ith value, which is moving from left to right, it becomes equal to the current value, the current maximum, I will change my current maximum. So now after my I become equal to the last value or the last maximum I have reached, my new maximum will be the current value stored among all of these maximum. So as you can see, my new maximum reach will become equal to the current, which means current is storing out the maximum among all of those values, and my answer will become increased, because now I have among all of these values, if I want to reach among all of these values, it will take you 1 step. So now because now I have incremented or go to the next, like as you can see, this is different slots, okay, different intervals. So among all of these intervals, it will take you 1 step. Among all of these intervals, it will take you 2 steps, because from this will mark out to be a new interval, because okay, from the first step I can go to this. So among all of these values, I can reach in 1 step, but from this I can go to the new step. So this will mark out to the next interval. So because it will take you 1 step to go to this and the next step to go to this. I hope you understand the logic. and whenever my I, because I will move from left to right, it will becomes equal to the last maximum. The new maximum will be the current maximum among all of them. It will go to this, and my the number of answer become +1. Okay, and my I is moving from left to right, so it will always increment by 1, and that's the answer. You can go down to the code again to make it even more clear. If you have still any doubts, you can mention down. And the game 3 is also very simple. It is just a DP problem in which you are actually given that you are given an array, you are given a starting point like a starting index, and you have to keep on doing a jump, which is that if you are on the ith index, you can go from the ith index to like I minus ARR of I. So if you are on the third index, you can go 3 jumps forward or 3 jumps backward. So from any index you are, you can either go to 3 jumps back or 3 jumps forward, and you have to keep on doing this such that you can land on any value which is 0. If you can land on any value which is 0, then it is okay, else you cannot do this. So it is a very simple problem because let's assume that I have some values. Let's assume that I'm on some current, I am on some value. Now I can reach to some value which is I can either go the same step backward or same step forward. If I go some backward and if it goes out of bound, then it is not necessary to go to this step. Now if I want to go some forward step, then this step maybe lead down to some new step, and that step maybe lead down to the original step. Okay, because I can also go out of bound, but this is not possible. But I can go back. But if I go to the back step, then I can reach down to the same value, and then it is like an infinite loop. So I cannot reach. Maybe there is some 0 value here. These are actually the number of steps, which means that number of steps maybe this is equal to 3. So I can go 3 jumps here. This is 3 jumps here, and this is my 6. So I can go 6 jump back. Okay, but there is some 0. So it is like an array. Okay, it's like an array 3. Okay, and then 2. And then 3, and then 0 and 6 and so on. So it means that I can go from this to 3 jumps forward. Okay, so that's what I'm trying to say. And so as you can see, maybe there is some 0, but you will not reach that 0 because maybe your starting index is this. Okay, so you have to somehow find out a way. So as you can see, if I start at some index, I have always 2 options. I can go to this way, I can go to this way. Okay, maybe I can go to this way. If I go to this way, I can go I have 2 options. I can go to this way and I can go to this way. If I go to the previous way, then you can always make a visited vector, which means that if I make a visited vector, it is not always beneficial to land on the same value, because if you land on the same value, you have started, which means that you are making some cycle. If you're making some cycle, you cannot never reach out to 0. So it is always beneficial to not go to the same block again, because if you are going to the same block again, which means that you are making some sort of cycle, going to this and going to this, going to this. So if you are going to the same block again, it means that you have to you are making some cycle. So it's not beneficial to the game to going to the same block. So you have either you can either go to some block which is not visited, or if you go to some out of bound region, it is not beneficial, or if you go to the block which is it is already visited, so it is not beneficial. So you just have to do some jumps, like DFS jumps. So at max you can do O of n jumps, because you can do at most you can jump to every block. Okay, then you can go out of bound, or you can tell that it is not possible. So the maximum you can do is O of n jumps, and in that you can tell that whether you can reach some block which is 0 or not. And that's the whole logic. This is very simple. So you can make some because the maximum value is this, so I make a boolean vector, and this is I'm setting it to false because everything is false. So I just take a DFS from this is sending this array, and this is start variable on which you have started the starting index. And then you have 3 conditions in which you can go out of bound, or if it is already visited. If it is already visited, then the answer is false. Else, if you land on some index which is 0, because you have to somehow land on an index which is 0. If you land on an index which is 0, then the answer is true, obviously. Else, you have 2 conditions. Because you are on some index and it is not visited, you have to first make it visited, which is making this true, and then from this you can either go to left or right. So the new starting index will be, you are sending this the array itself, and the new starting index will be start plus ARR of start, because on the current index you are, the current indexed the current index value is ARR of start of I. So ARR of I, so I is actually start, so ARR of start. So we are adding this to the current start on which we are. So start actually storing out the current index I'm on. So you can either go from the current index plus ARR of start, or starting index minus ARR of start. And if any of them is giving true, so we are just doing an OR of it. So, and we have to return it out. and we are storing out whether we have like visited this particular value again or not. So I hope you understand the logic as well as the code for this problem also. I have discussed all the 3 problems. If you still have any doubts, you can mention out. I will link it down all the codes in the description. So still tuned. I'll see you next one. Keep coding. Bye.